Greetings. This is MAT181 pre-calculus trig. My name is Neil Mitchell, and I'll be your teacher for this lesson, 1.1, angle basics. And what I will be using on this is Texas Instrument TI-30X2S. And this is, you can use other calculators, but I prefer this calculator. So, well, let's get on with the show. What do you think? So I lost my document. Here we go. All right. So the first thing we want to do is clear this off, and let's talk about some angles. An angle basically is a point where two rays are generated from it. This point is called the vertex, and two line segments connected at a single thing. These are called rays. These rays connected at a single point called a vertex forms an angle. When we measure an angle, the initial side is the side we start with, and we rotate in a counterclockwise direction to measure the angle. And the ending side is called the terminal side. So this would give us a positive angle. When we go in a counterclockwise, for instance, this would be notated with a little thing like that, and it would be called 30 degrees, let's say. And that would be this particular angle, and measure it by a protractor or whatever. If the angle goes the other way, let's draw one going the other way, this would still be the initial side. But now we're going to go this way. And this is your terminal side. And this would be measured as a negative angle, maybe a negative 45 degrees or whatever. This would still be our vertex right here. We usually designate it with a letter, maybe A, maybe B, whatever. So that would be our initial side and our terminal side. Okay, so that's kind of how we measure an angle. If it's going counterclockwise, it's positive. If it's going clockwise, it's negative. All right. Angles are broken up. A circle basically has 360 degrees. So an angle of one degree is 1 of 360 degrees. It's basically the way it works. Now, key angles are 0 degrees. Well, let's try this a little bit better. Erase this. Give you some graph paper. Okay, so when we have this drawing here, this angle right here is 0 degrees. If it's straight up and down, of course, it's 90 degrees. If it goes this way, it's 180 degrees, 270 degrees, and then it goes back. So 0 and 360 are really the same angle. Okay, so we're going this direction, counterclockwise around here. So anything in this area is an angle that's acute. An acute angle is an angle that's less than 90 degrees. So we would measure this way, and angles from here are actually from 0 degrees to whatever our angle is here. Sometimes we use different symbols for our angles, theta and alpha, and we can use letters or whatever. Let's just call this X, is less than 90 degrees would be in here. So anything between 0 and 90 would be in this category. In this category, it would be anything from 190 degrees, less than X is less than 180. So it would fall into this category. And then from 180 to 270 would be in here. And then from 270 to 360, whoops, there, would be in here. So these would be our things. So let's look at an angle in here. The angle would look like this. We would measure it that way. An angle in here would be, this would be called an acute angle. This would be an obtuse angle. And it would look like this. So acute, obtuse is more than between 90 and 180. Okay, but in here, let's take a look at an angle in this, what we would call these quadrants, the first, the second. Let's look at an angle in the third quadrant. An angle in the third quadrant would look something like this. Maybe that's our angle. But we're not going to measure this way because that would be a negative angle. We want to measure positive. So the angle is measured on the outside. On the outside, it would be positive, and maybe it's like a 235-degree angle. So this would be our angle. If we were measuring on the inside would be negative. This would be a negative angle. And that would be right in here. This would be a negative 125. And we'll figure out how to do that later. But this would be negative if we're measuring here, but we're measuring the angle counterclockwise. So sometimes that's a little deceptive. You know, in math, we're used to measuring the inside, but got to think outside the box. So then this angle, what would this angle look like? Well, this angle would look like this, but we would be measuring it this way. So it would be maybe 330 degrees, and we would put it like that. We wouldn't want to put it inside because that would be a negative angle. So we usually want to call angles, use angles by their positive names. So that kind of gives you an idea what the angles are. Okay, so this is kind of a little rough estimate of what angles look like. Okay, another thing we can do with angles is a lot of times we know this is a 90-degree angle. We designate it with a little box like that. But sometimes we want to figure out two angles. So when these two angles add up to this, what's called this angle B and angle A, when these two angles add together, they're called complementary. Complementary. Angles, let's just put a symbol for angle. Those two angles, angle A plus angle B, are going to equal 90 degrees. The way I remember this is 90 degrees is what we call a right angle. And when you pay somebody a compliment, it's the right thing to do. So complementary right angles, they add up to 90 degrees. Okay, supplementary, and you might remember this from geometry, or, you know, it's been a while. So supplementary angles are two angles that will add up to 180, and 180 is a straight angle, huh? You got your acute, you got your obtuse, you got your 90 right angle, and you got your straight angle, which is 180 degrees. So supplementary, two angles are going to add up to, because it's a straight angle, 180 degrees. And a picture would look something like this. Here's A, here's B. And the distance, the total distance here from here to here is going to be 180 degrees. So we call those supplementary angles. And the way I remember that is supplementary is a straight line. Okay, we eat our supper on a table, and therefore these two angles are supplementary because we have our supper on a straight line, which is 180. I don't know, that's how I remember it. So sometimes we like to trick students, we like to have little problems with this. So I'm going to make up a problem. I know it's probably not the best of problems, but I'm going to try to make up a little problem here. So let me erase this. Let's say we have two angles here, and we're trying to figure out these angles. But one of these angles is going to be 2x plus, let's call it 5. And the other equation is going to be 3x plus 5. And we've got these two angles. And we're trying to figure out what are these angles. Okay, what are these two angles? So in order to do this problem, we realize that these two angles are going to add up to 90 degrees, right? So 3x plus 5, angle 1, call it A or whatever, plus the second angle, 2x plus 5, have to add up to 90 degrees. So now all we got to do is a little algebra here. And you might, again, remember this a little bit from geometry. 5x plus 10 equals 90. And we're going to subtract 10 from both sides. So 5x equals 80. And all we got to do is divide both sides by 5. And x will be 1 and 6, 16. But that's x. That's not the angle here. We haven't determined the angle. So let's call this angle A. Angle A is 3x plus 5. Now we need to substitute back in. We only figured out x, but we didn't figure out the angle. So 3 times 16 is 48, plus 5 is 53 degrees. So that's what angle A is. Now, if I wanted to find out angle B, all I've got to do is take 90 minus 53, and I would get 37. But we can also substitute in, let's call angle B 2x plus 5. We can also do it this way, kind of double check our work. So 2 times 16, 32, plus 5, 37. So this would be a way to double check. And so we know angle B is 37 degrees. So just when you find X doesn't mean you found your answer. This is the answer to the problems. Now we could do the same thing if these angles were, these were complementary angles. If these angles were supplementary, if they added up to 90 degrees, we could also do the same thing by simply, instead of setting the equation equal to 90, we would set it equal to 180. I think they have a little simple one in the book. Let's try this one. You have this angle here. I guess it's drawing the opposite. And this was 4x and this was 6x. So all we got to do is say, oh, okay, 4x plus 6x is 180 because this is supplementary. So this is 2x equals 180, divide by 10. 10, now I said 2x, 10x. So x is 18. But didn't solve the problem. So this angle right here is 4 times 18, that'll be 72. And this angle right here is 6 times 18, which is 108. And we see that those two angles are going to add up to 180. So there's our two angles, A and B. So again, X is good, but it doesn't give us a total answer. This is the answer. All right, so we talked about supplementary and complementary angles. Another thing we want to talk about is how do we name angles? Well, normally we name an angle as like 30, sorry, change this, like 37.34 degrees, something like that. We usually use decimals, it's the easiest way. But we can also name an angle with degrees, minutes, and seconds. And so we can also do that. We can call this 37 degrees, 6 minutes, and 14 seconds. We use a single bar for minutes and a double bar for seconds. So this is minutes and seconds, and this would be like an hour, okay? This would be almost equivalent to an hour. So 1 minute is 1/60th of an hour, and 1 second is 160 times 60, or 3,600 seconds of an hour. In other words, 3,600 seconds makes 1 hour. And if you don't believe me, you can just kind of count. Okay, just kidding. So that would be 1 second is, there's 3,600 seconds in a minute. Okay, so what if we had a little problem here? We have I take the one out of the book. We got 51 degrees, 29 minutes. And to that, we want to add 32 degrees, 46 minutes. So we want to add these together. Now, there is a key on your calculator that has this sort of marking and a couple other ones. You can use that thing, but actually I think it's just a little bit faster just to do it directly. But if you wanted to mess around with that key, you can. Here, find it in your calculator, so I get the third column towards the top. But let's do this just without using it. 51 degrees, 29 minutes, plus 32 degrees, 46. In fact, we'll do this without a calculator, period. We're just going to add these up. This is 75 minutes, and this adds up to 83 degrees. Okay, so we get 83 degrees, 75 minutes. But 75 minutes, there's only 60 minutes in an hour. There's only 60 minutes in a degree. This is too big. So what we're going to do is we're going to subtract off 60 minutes. We're going to kind of reduce this by 60 minutes. But because we're taking away here, we're going to add another degree here. So 1 degree is 60 minutes. So we're adding to the degrees, but we're taking away from the minutes. And so this gives us now 84 degrees and 15 minutes. And now we have the problem solved. And we want it in this form because this is reduced form. If you put it in this form, obviously, it's not going to be correct. Okay, another problem they had was 90 degrees minus 73 degrees, 12 minutes. Okay, but if we go to subtract this, we don't have any minutes to subtract from. You can't just project it down. We have to be able to subtract from something. So once again, we're going to change this. I'm going to erase this out right here. And we're going to change this 90 minutes to 89 degrees. Did I say 90 minutes? We're going to change 90 degrees to 89 degrees, 60 minutes. Because again, 60 minutes is 1 degree. So if we take away a degree, we can add 60 minutes. So now we can subtract 48 minutes. And here we can subtract and get 116 degrees, 48 minutes. I might have copied the problem. Yeah. So that's our answer to that problem. And that would be the easiest one. Okay, another problem we got here is sometimes you see this problem, it's written in, this is what we call conversion. And those problems, we were just calculating with, doing some calculations. But here we want to convert. A lot of times we run into conversions, we need to do them. A lot of times we don't want to work at, we have an angle, according to the book, it's 64 degrees, 8 minutes, and 14 seconds. And we don't want to operate in degrees, minutes, seconds. We want to convert this one to 74 point something. And the book says, let's change this to the nearest thousands. And DTHS. Okay, so thousands would be 3 decimal places. But we're probably carried out to 4 decimal places and then reduce it. So we have 74 degrees. Well, 74, we don't want to do anything to. That's fine. But we want to convert over this 8 minutes. And we know there's 60 minutes in a degree. So this is 8/60th. So we're going to add plus 8 over 60. And we know that seconds are, to change over seconds to minutes, there's 3,000 seconds, 3,600 seconds in a degree, or there's 3,600 seconds in an hour. So we want to take this 14 and divide it by 3,600 to get its decimal equivalent. So now obviously we're going to use a calculator. We're going to divide 8 by 60 on the calculator. It comes out 0.133. And we want to go beyond 1,000. Okay. One more place. Plus, then we want to divide 14 by 3,600. So that came out to be 0.0039. So now we're going to add all this together. We got 74, which is a whole number, point, and we're adding up these decimals. This would be 1, 3, 7, 2. Okay, but we want to only go out to the thousands, and 2 is too small to round up. So we're going to just call this 4.137. And we want to make sure we label it as degrees. Okay. So that's how we do it. Minutes, if it was just in minutes, we wouldn't have to do this. Maybe it was just 74 degrees, 8 minutes. We just take the 8 divided by 60, get a decimal, 74.133, or 74.13 even, but this is it. So now we have, let's say we have it in degrees, but we want to change it over to minutes and seconds. Why would we want to do that? Well, when you get by your property is usually labeled in, technically it's labeled like 30, the property line, because you have to draw, you have boundary stakes that are put into the ground, and you have to stay within your boundaries. If you go beyond it, you can get sued or whatever. So they're always in minutes and 77 minutes and 3 seconds or something like that. They're measured that way on property description. It's also on navigation. Sometimes we still do it. So we want to convert this over. So we're not going to do anything to the 34 degrees, okay? That's still going to be our 34 degrees. So now what we're going to try to do is convert over this 0.8167 to just minutes. So maybe we just wanted it in minutes. So what we're going to do is we're going to add, and we're going to take this 817. And last time we were dividing by 60, so instead we're going to multiply by 60. We're going to times this by 60. And that should give us, and we do this on our calculator, we get 49 0.02. Okay, so this is really meaning that we have 34 degrees, 49 minutes. But we still have this little left over, so we want to change that to seconds. So we're going to take this 0.02 and we're going to multiply it. And you might think we're going to multiply it by 360, but we're just going to change that over to kind of like its relationship to minutes. So we're going to multiply this by 60. And that gives me 1.2 is what it happened when I multiply this out. So then that would be the seconds. This was minutes. Now we've got the seconds. We take this little remainder part, just like we took this little remainder and put it there. And then we want to, 1.2 is still under, it's pretty small. We don't want to get, we could go probably smaller than seconds, but we're going to just list this as 1 second. So this is 34 degrees, 49 minutes, and 1 second. You could write it like that if you want to be fancy. Okay, and so we have this angle now written in. So we take the 34, just drop it down, convert to 49.8, drop the 49 down, take the 0.02, multiply by, and get rid of that 0.2 part because we don't want to go any smaller than seconds. So let me do this better. It's gone. Okay, converted. We talked about terminal sides and initial sides. Quadrangles, we talked about quadrantals. So the key thick angles here, 90, 180, 270, 360. They divide up or 0. They divide up these quadrants. So we call quadrangle angles. We'll talk more about those later on. We talked about, okay, now we want to talk about, let's say we have an angle here. And this angle is, let's just call it 30 degrees. Okay? And that's from here to here. But maybe we have another angle that falls right on this angle and goes around this whole thing, 360, if I can draw a decent circle, and comes back. And this is a 390 degree angle. So angles don't always have to be under 360. They can be more than 360. They can go all the way around and come all the way back. So that would be a fairly large angle, huh? That can go all the way around. Likewise, we could have, let me try this again. Maybe we have an angle right here. That's over here. Let's say this angle right here is 135 degrees. We could go all the way around again and come back there and have another angle, 495 degrees. So, we can have large angles, but usually when we're describing an angle, we want the smallest positive angle. We could also have this angle have gone around this way, and then this would have been a negative 330 degree angle. So angles can be measured various ways, but the best angle we want is the one that's the smallest and positive. Sometimes we have to deal with negative angles, but we really don't want them. So how do we do this? Let's suppose we had an angle that's very big and we want to calculate it out. So here we have a 908 degree angle. Wow, pretty big. So what we can start to do, what we can think about this angle is, maybe this angle is somewhere, according to the picture, it's like maybe over here. And they went around and around and I got to this angle. So what we want to do is not all that stuff. We want to just figure it out mathematically. So we could subtract 360, get an answer, and then subtract 360 again and get an answer, and keep doing that. But I kind of realized that 360 times 2 is 720. So instead of doing it over and over again, I'm just going to subtract off 720. I can see if the angle is bigger than 720, then I'm going to subtract off 720. And I can just do this without my calculator, I think. Hopefully get it right. 188 degrees. Okay, so that would be the smallest angle. It's still a pretty big angle, but it is a positive angle. If I can't subtract off 360 anymore, I've got the angle. So this angle, what we say 188 degrees, is coterminal with 908 degrees. So this angle right here, now 188 degrees, where would 188 degrees? 90, 180, 188. This angle is right here. And so is a 908 degree angle is the same thing. But this angle went around once, twice, and partly almost 2.5 times. But this is the same angle, 908, 180. Okay. All right, let's try another one. Here's an interesting one. This angle is a negative 180. I'm in a negative 80, negative 800. Let me take a look at it. And it would be a little hard to draw a negative 100, negative 800 angle. That's what I want to do. So, okay, the brain is not catching up with a pencil. Negative 800 degrees, okay. So how would I do it? I do it a little different from the book. I don't know, maybe they do it one way, I do it another way. Okay, so I know this is going around quite a few times, so I'm going to add 720 to this. Okay, I know it's spinning around quite a few times negatively. It's going all like that in that direction. So that gives me an angle, but it's still negative 180, negative 80, right? So now what I'm going to do is I'm going to subtract that from 360 to get a positive angle, because this is positive, it's bigger than negative 80. If I subtract these, I should get my angle right here. And let's see if I do it right, 0, and this would be 8, and this would be 280, right? So my angle is 280. So I did it a little differently from the book. The book went ahead and said, well, if it went around 3 times, it would be so much. But I think that's a little confusing. So remember, you're just working with integers here. A negative and a positive. The negative is bigger, it's going to come out a negative answer. Here you have a positive and a negative, it's going to come out a positive answer. So when you have a negative angle and we want to change it to a positive angle, all you got to do is subtract it from 360. If it's, a small angle, if it's huge, well, then you've got to narrow it down to a small negative angle and get it there. Here's another one. Suppose I had give you an example. The book has a negative 75 degree angle. So I want to name it positive. Just take a positive 360, subtract off 75, and this should give me a positive angle, see, because, and of course, maybe I'll borrow and all that good stuff, but 285. So this would be a positive 285 degree angle. So you can, if an angle is coterminal, whatever your angle is, you're just going to add 360 to it, and this will give you a coterminal. And you can keep doing that. Like you could add 720 to it, or whatever, just so they're multiples of 360. And that would give you a coterminal angle. If it's negative, then you're going to have to do a little bit more work, but you can calculate it out. So in the book, they show some angles that are coterminal, So good. The last problem we have is a kind of an interesting little problem. at the CD player, and it's going at it's turning at 480 revolutions per minute. And we can abbreviate like that, revolutions per minute. And we want to know how many degrees will point on the edge of the thing turn in 2 seconds. How many degrees does it turn in 2 seconds? So how do we do this? Well, think of this. Okay, here's this record, and it's going around and around and around and around. In 1 minute, it's going around 480 times. Okay, so we want to try to figure out how many times it's going to turn in just 1 second. Okay, so we want to change 480, let's just do it down here, 480 minutes to seconds. So what we're going to do is we're going to divide this by 60 to figure out, because a second is 1/60th of a minute. Okay, 1 minute is equal to 60 seconds. We can think of it that way. 1 minute is equivalent to 60 seconds. So I'm taking 480 minutes and I'm multiplying it by 1 minute over 60. So I'm just doing it this way. So that means it's turning at 8 revolutions per second. Okay, well that's great, but it doesn't answer our problem because we want to know how many degrees it's going to turn in 2 seconds. So in 2 seconds, it's going to multiply this by 2. That's going to give me 16 revolutions per second. Okay, well that's great, but we still don't know how many degrees that is. Well, 1 revolution is how many degrees? If it turns 1 complete revolution from here all the way around, it's turning 360 degrees. So we're going to multiply 360 times these 60 revolutions, and that should turn you to degrees. So 360, I'm actually going to use my calculator, 360 times 16 is 5,760 degrees. Now, why you would want to know that, I have no idea. But that's how many degrees it is. So it's traveling at 480 revolutions per minute. It actually has turned 5,760 degrees in 2 seconds. In 1 second would be half of that. So, so it's turning about, well, we could just multiply in 1 second. It was 8 times 360. (2,880) revolutions in 1 second. So anyhow, could play with those problems. I think I assigned one. It's not a big deal, but you might want to kind of figure it out a little bit, kind of a thinking problem. And that's what trig is. So let me give you one more little insight. Let me clear this out. The trig that you're going to be studying is called plane trig. Plane trig means that we're working with just a 2-dimensional surface, flat, like this grid. There is also another type of trig called spherical trig, which deals with 3 dimensions, like, traveling trig in space, like trying to find a triangle in space, which doesn't have straight lines. So it's kind of confusing. So what you're dealing with, and most of the time on Earth, we're just dealing with plane trig. Okay, now plane trig has 2 parts to it. It has a practical part, and that's what you're going to study first, the practical part, like we did. Converting an angle with coterminal angles, trying to find what the supplemental angles are, that type of thing. That's the practical approach. Trying to solve a triangle, trying to find the angles and the sides of a triangle. It's more powerful than geometry because geometry just deals with specific triangles like 30, 60, and 45-degree angles. But trig can handle any triangle, but it has to be a right triangle. It has to have 90 degrees in it. Later on, we'll figure out how to get around that a little bit towards the end of the course. But for the most part, we have to deal with just right triangles. But that's the kind of the fun part, kind of calculating. And that's how we survey properties and stuff. We can use transits and stuff like that. We use other methods now that are a little faster, but it can't be done that way. The other part of trig is what we call the abstract part. The abstract part deals with graphing functions and working with complex problems like polar coordinates and inverse functions and things like this. So that is the abstract. Proving identities. We have to do a lot of proofs. We have certain identities, certain relationships, and we use these relationships to prove other ones. So that's the abstract part. So there's two parts. Some people like the practical, some people don't care for the abstract, some like either one, or whatever. So keep that in mind. The other thing is you're going to be taking a quiz. You can use your homework. I don't collect the homework, and there's an assignment. But you can use that when you take your quiz, so you have examples. You can also use your book as a reference. But these quizzes are timed, so you can't spend a half an hour looking at one problem. There's probably a time limit. I usually allow 60 minutes, and that includes the time to upload and download and do whatever and send that quiz back to me. That's included in the time limit on this quiz. So you have to make sure you get all that done within the 60-minute allotted time, or however minutes you're given, depending on the number of problems and so on. So keep that in mind. But you can use your homework, and that's why you want to practice the homework, so you're pretty speedy when you can do the quiz. Problems are similar to the homework. The other thing is you only have a certain amount to submit these problems. At the end of the week, you have to submit them by Saturday at 11:59 p.m. You can't go into your computer and say, okay, I'm going to take the test at 11:30 at night on Saturday and figure that you're going to get the quiz done and submit it by 11:59. If it's too late, then it's what we call a zero. Now, we will allow maybe 4 drop zeros for the course, but if you don't submit something. But just bear in mind that you only have so much time to get these in. Once that deadline is not met, you can never go back. You can never go back. You can do these quizzes anytime during the week. You can do them on Monday, Tuesday, Wednesday, Thursday, and submit them. But if you don't submit them by that Saturday, it's too late, and you forfeit your chance to get those quizzes in. So you want to make sure, if you're absent from school, you still are required to turn all this stuff in. So anyhow, that's it. So I hope this was a little long. I hope the other ones aren't quite as bad. But I want you to stay healthy and stay smart, and I'll see you next time.